Let's continue talking about Fabric device roles. In this case, we're going to talk about the border nodes. The border nodes are these devices here, and the border nodes are the exit point of my fabric. So I will connect non-fabric networks to my fabric, and even I can connect other fabric networks to my fabric through the border nodes. I can connect, for instance, the internet. I can connect, for instance, my wide area network. I could connect, for instance, an on-premise data center, or I can connect, for instance, a shared services block. I can connect, for instance, another fabric. So the border nodes are the exit points of my fabric to non-fabric networks and other fabric networks. Remember that in order to run your enterprise network, you need a DNS server, for instance, a DHCP server, and your Catalyst Center, formerly known as DNA Center, your I server, and these servers may live in your shared services block or they might live in your on-premise data center, depending on your network. Your on-premise data center is considered to be an internal network. Your shared services block is considered to be an internal network. The internet is considered to be an external network. And your wide area network, that is open to debate. Some documents refer to it as an external network, and others refer to it as an internal. So that is up for debate. And given we are running Lisp in our fabric, these border nodes are performing the functions of PXDRs. So remember, the border nodes is the exit point of your fabric, and they are the PXDRs for your Lisp protocol. They are also in charge of maintaining the scalable group tag and the virtual network ID information when traffic goes outside your fabric. Remember that inside the fabric we use VXLAN tunnels, and these VXLAN tunnels have headers, and we are using some fields within these headers in order to carry a scalable group tag and BNIDs. But if we want to maintain this information outside the fabric when traffic goes outside the fabric, and then the border nodes will have to rely on some features of TrustSec, such as inline tagging or the SPX protocol, in order to maintain this information outside the fabric. So the border nodes will be using inline tagging or SPX protocol in order to keep this information when traffic leaves the fabric. Remember that they are also the exit point of the fabric, and they are the PXDRs for the Lisp protocol. And they are also VTEPs. In VXLAN terminology, our border nodes should be able to encapsulate traffic into VXLAN tunnels that coming from outside the fabric into the fabric, and they should be able to de-encapsulate traffic coming from VXLAN when traffic is moving out of the fabric. So the border nodes are VTEPs. That means that they will be able to encapsulate and de-encapsulate traffic. They are also in charge of maintaining the scalable group tag and BNID when traffic leaves the fabric. They are the exit points of the fabric, and they are the PXDRs for the Lisp protocol. There are several types of border nodes. We can talk about layer 3 border nodes. or layer 2 border nodes. Within the layer 3 border nodes, we have external border nodes, we have internal border nodes, we have anywhere border nodes, and we have guest border nodes. Regarding layer 2, we have something that is known as handoff border nodes that are operating layer 2. We're not talking about that in this session, so let's focus on layer 3 border nodes. When we are connecting our border nodes to external networks such as the internet, we are said to be using external border nodes. These external border nodes will not register any endpoints IDs at all. So remember, when your border nodes are connected to the internet, they are known to be external and they will not register endpoints IDs at all. We can also have our border nodes connected to internal networks such as data center or a shared services block. In this case, when these border nodes receive prefixes arriving through routing from the data center or from your shared services block, what these border nodes will do will be registering these prefixes to the control nodes using map register messages. So in this case, our border nodes are said to be internal border nodes. So remember, when your border node is connected to a data center or to your shared services block, they will receive prefixes that may be summarized networks, and they will register these prefixes as endpoint IDs with the control nodes. And in order for this to work, we will need fusion routers. So we have fusion routers here that will help us map prefixes that live within virtual networks that work like VRFs, in order to have devices that live between inside these virtual networks to talk with servers that live in the global routing table in networks outside the fabric. So for instance, you might have a device here, for instance, a device A that lives in VNA A, and this device B that lives in VNA B. The prefixes that are assigned to these devices lives in separate routing realms. So these are completely different domains. But for instance, your DNS server that lives in your shared services block lives in the global routing table. And you need these devices to be able to reach the DNS server. But these devices lives in different VRFs. So when these prefixes arrive into the fusion router will map these virtual networks into VRFs, and then it will perform route leaking. So it will leak these VRF routes into the global routing table. So the DNS server will be able to communicate with these devices, even though the DNS server lives in the global routing table and these devices live in separate virtual networks. That is why we need fusion routers. We're going to talk about fusion routers in more detail in another session. Now, if your border nodes are connected to both external networks and internal networks, so that means that your border node will behave as an external border node, and it will also behave as an internal border node. That is said to be an anywhere border node. So an anywhere border node behaves both as an external border node and an internal border node. So for prefixes coming from your data center, this anywhere border node will register those prefixes using a map register message to the control nodes. And for prefixes that come from the internet, the border node will not register those messages. So for a regular size network, you might only need two border nodes that are anywhere border nodes, because you will only use these two border nodes to connect to your data center and to the internet. But if your network is large enough, you might need more border nodes. So if your network is a large network, you might need two border nodes in order to connect to the internet, and two separate border nodes in order to connect to your internal network. So you will need two external border nodes and two internal border nodes for a total of 4 border nodes for large networks. And for not so large networks, you will do just fine with only two anywhere border nodes. So that depends on your design and the size of your network. There are other types of border nodes that are known as guest border nodes. If you are hosting your guest network in a DMZ, you will need to place two guest border nodes in your DMZ. That if your guest design uses a DMZ. There are several ways to design guest networks for your fabric. One way of doing it is using a DMZ. If you are using a DMZ for your guest traffic, then you will need two guest border nodes. So that means that if you're using this solution for your guest users and your network is not that large, you will need two anywhere border nodes and two guest border nodes for a total of 4 border nodes. But if your network is larger, if you have a really large network, you will need two external border nodes, two internal border nodes, and two guest border nodes for a total of 6 border nodes if you really have a really large network. So in summary, we have several types of border nodes. We have a layer 3 internal border nodes, layer 3 external border nodes, layer 3 anywhere border nodes, and layer 3 guest border nodes. And we have also layer 2 handoff border nodes that we're going to talk in another session. Internal border nodes will register endpoints. External border points will not register endpoints IDs. Anywhere border nodes will register some EIDs and will not register some EIDs. And guest border nodes are used when you are designing your guest solution using a DMZ. That's it.